Good morning, everyone. Today I continue showing you how to do the crash port analysis. Crash port is a very important part in automotive to reduce the impact energy during the collision. During the impact, shock energy will be converted into strain energy or internal energy by crumbling of the crash port. So today I will show you how to do this kind of nonlinear buckling analysis. So there are two parts here. So one part, the hexagon part, which thickness 1 millimeters and flange is 2 millimeters. So firstly, we need to create a meshing for this part. So we go here with a freeform mesh, and we choose mesh size here maybe 3 millimeters. Okay. Okay, it's 3 millimeters. So I just right click to confirm the mesh sync. Yeah. So we can turn off this cap to see. So I think this part very simple. So the mesh quality is very good. So we can check the free edge. Yeah. So we can check his element and review. So this have a red color here. It means that there are some unconnected mesh in this area between the flange and the hexagon. So we need to equivalent this mesh. I go to the equivalent and here preview, and we can equivalent and we can check again. Okay, review goes. Now it's correct, right? So next step, we will create the material for this kind of part. So I already create some material here. Actually, I can delete this guy. Okay. So I create material. Okay, so I choose this and choose plus Johnson Jerry. So I key the name here aluminum. I assume it's aluminum. Okay, and the row ratio I choose this number. Okay, we can this. I choose the 26A minus 6 is density and young modulus 7.7. This in this system we use kilogram, kilonewton, millimeter, and millisecond, and GPAs. Actually, I have a tool to highlight you the consistent of this model. So we use this unit system, the kilogram, millimeter, millisecond, and kilonewtons, and gigapascal. Okay, so there's a gigapascal. Generalist is a 71.7 gigapascal, and V is 3. And here I choose this classic Johnson Cook parameter APN, and I choose sigma E, yeah, sigma Y. Okay, B, okay, and N is focus 1. Okay, so we finish create a material for this kind of part. Okay, in order to see the sub entity, yeah, you can apply this, then you can see and edit the information. You can go to view to show the entity editor. Okay. So the next step, we will create the property. So I create the property. Okay. So here I be 1 millimeters. Okay, I can double click here to go to this property on shell, or I can double click on property to open this. Okay. Shell 1, I shell again, I choose QEPH 24 formulation, and I choose number is 5, and it needs 1 millimeters. Okay, so we already have copy one shell. Yeah, we can keep the other parameter default, then you can duplicate Sorry, you can just duplicate this and I choose D2mm and you just modify this to 2 millimeters. Okay, so now we already have the thickness, so you can check again the thickness table here, the one for which we can edit here is also possible. And next we can assign information for this cheese. I choose property to 2 millimeters, aluminum. Okay, same. I choose this 1 millimeters and aluminum. Okay, so but here you should remember we change this to the cut part. Okay, with the cut image in the part. Okay, 2 millimeters. So you can quickly see here like by the thickness everything. Maybe that's fine. Next, we need to create a resist element to pushing the load on that. So I create a resist. Okay, resist component. You can click here to switch into the empty cut, non-cut to contain the resist body element. So I go to the model and choose resist. Okay, so I can right click here and I select all of this. Okay, so now I already have now. You see I can change color this guy, or easy to see. Okay, so that's we already finished some element and meshing. So next we will set up analysis. So okay, now we moving to create the reservoir. So before this one, we need to choose a base node. I go to topology, choose here, create free node, and you keep the control button on our keyboard. Okay, and here you create the base node here. So now I just right click here, create reservoir. Okay, this is one. I put a name like this, and I choose base nodes here. Sorry, I choose a base node. This is four here. Sorry. Choose this. Firstly, I come back and create it. You need to right click or middle mouse to create this tab node. And now we go to reservoir, we select this guy. Okay. Sorry. Select this. Confirm. Actually, you can assess a little bit for this. Maybe this is equally to 0, but I choose 0.1. Okay. And next, we need to create a direction of the reservoir, right? So I choose in Z direction, right? Okay. So now we already have a reservoir, and now we choosing the sliding time or sliding with friction, whatever. So I choose here the third distance maybe 10, 10, okay, and friction 0.1, okay. So after finish, you can right click to review to see the slider node automatically recognized based on distance and the reservoir. Okay, so that's why we finish setting up for the reservoir. Next step, we need to create a cell contact for this. So I just create a contact here. I choose cell contact. Okay, I choose tie here, tie 7. Yeah, you can right click here to create the set a node. Here I already have a macro to do this. I choose a create a group node. So I choose a group node is a name cell contact. Slaver is not right. And then I choose this all of this part. Okay. Choose two of this part. Then I hit an OK. Confirm. So I already create a set. So double click here, you can see the cell context, that's right. It's a rigid body, right? And now I create another group surface extension, cell contact, master surface, and I choose this component as well. Okay. So now I have this kind of extension. You can make this script very easily. Okay, just record. You can using script to record and command file to record and copy and modify. Use TCR script, or you can manually trace this. So now I have group, right? So it's contact here type 7. So I just choose slaver, faster, master. Okay. So you can choose number 4 or whatever. So I get mean usually is half of thickness, so I choose this 1, and fixing is 0.1, and the rest I will keep the default information. Okay, so we can right click to review. Okay, it's red is a slaver and master is the blue color. So escape. So almost fine. We create the contact, and now we create the impulse displacement. So how to create the impulse displacement? Before that, I think we need to create a set of node. So I create root node here. I put as a center B. Okay, so I create a grid of set node here. Okay, so right now I already have a set. Yeah, it's a center of it's one node, right? I can right click to review it if you want. Okay. So now I go to the analyze. I choose enfold displacement. It does the impulse displacement. So I right click here. So I choose impulse displacement here, and I choose set is the center of the body. Okay, and I think we need to move this part in minus z direction, right? So I choose here the z direction. Now I can right click here, create the curve here. So I'll choose curve here from 0, 0. I choose, sorry, you can edit curve here, or yeah, you go to edit curve here, we can choose here 20, okay, 20 seconds and 1 meters. Okay, so already finished. Let's create a curve. So right now we here choose this. We can switch out this curve. Already have z direction, and now we go scale 1, and this we choose -1, right? Okay, -1. Okay, and this stop and this stop, maybe we get a 20s or 22. Okay, okay, we choose that here. So we finished about recognition, but we need to create another constraint, or else the tube will be roll over. So I choose this boundary condition again, and I choose this guy, center of our body, and I free the z direction, right? I lock all other degree of freedom. Okay, so here, so come back here. You can see we have load here. We have BC. We have impulse displacement. Okay, so okay, so this is almost done. Actually, you can go to the validate model, checking and run check. So this is only one name. No free node model. You can right click to remove picture, or you can check again the reservoir, right? We already checked, right? It's a review here, so ensure that all the nodes select properly, right? Okay. So now you can create the analysis. You can create a boundary the run engine system. I also have a script to do the same. Windows engine, I choose yes NT 0.5 and 0.1. Okay, and I create automatically create the output card, the animation time DT, run time, whatever. So now we can save our model and we can export. Sorry, crash pause here. Yeah, we have we run first time. Let's okay, save. And keep in mind, choose here how to export engine file export. So now we just choose our output run, right? This file. Now, okay, we can come back here. 100 dot Radioss. You can choose a number of CPU for running and choose 16 and run. During the waiting time run, we can split the window to prepare our model. Yeah, so I can change to hyperview to see the result, right? So here's keep running. Wait a minute. So we are finished running without issue, normal termination. So we switching this to hyperview and then we open the result. So we choose this S3D file after we running, right? Okay, apply. Okay, so we can use a contour to see the maybe the packet strings. I choose a simple one, apply. Uh, and now we can see the result. Okay, so we see we can maximize to see this result, right? Yeah, it's crumpling, folding, the crestboard will folding, and you see multiple. Okay, you see three layer, right? But we use a shell contact. Okay, so that's all for today demonstration video on how to create how to do the nonlinear buckling analysis for the crestboard. Thank you for watching.